We will discuss one more problem in material balance with chemical reaction. In the manufacture of chlorine by air oxidation of HCl gas, air is used in 20% excess of that theoretically required. The process is what? Manufacture of chlorine by air oxidation of HCl. Air is used in 20% excess of that theoretically required. Oxidation of HCl is 75% complete, 20% excess. Calculate the composition of the gases leaving the oxidation chamber. And in previous class we have discussed in detail how to calculate supplied quantities, theoretical requirements and all that. So here the process, first we will write here. The process is here, this is oxidation of HCl. Oxidation of HCl here. Now, what are entering here? HCl and air. And what are the leaving components here? And the reaction we need to write. What is the reaction here? HCl plus oxygen gives rise to Cl2 plus water. This is the reaction. If you balance 4 HCl here, 4H and 2 water and also 2 chlorine. Here 2 oxygen, 2 oxygen. Okay. So this is the let it be equation 1. And here what components are forming. And the conversion is what? 75% conversion. 75% conversion. That means the remaining 25 HCl is entering here and 75% only is converted and the remaining 25% is leaving out as unconverted. So first list out the actual products formed: chlorine and water. Chlorine, water, and oxygen is supplied, air is supplied in excess, means oxygen is supplied in excess. So excess oxygen, and because we are supplying air, here air contains oxygen and nitrogen. So excess oxygen and nitrogen what we are supplying along with oxygen in the form of air, and because conversion is only 75% unreacted HCl. Okay. So 1, 2, 3, 4, 5. 5 components are there. Now the question is calculate the composition of the gases. These gases composition leaving the oxidation chamber. We work out the problem on a mole basis only. That means composition of the gases means first we need to calculate moles of chlorine leaving, moles of water leaving, moles of oxygen leaving, nitrogen leaving and HCl leaving. First we need to calculate all those leaving moles. Then add up, you will get total moles. Then percentage leaving is, percentage chlorine leaving is moles of chlorine by total moles into 100, and same thing for the other components. This is our plan. So how to calculate moles of each component leaving by writing material balance for that component. Okay. And what information is given? Conversion is 75%. And what else information is given? 20% air is supplied. Air is supplied in 20% excess. 20% excess over that theoretically required. Over that theoretically required. Therefore, we can understand that oxygen is also supplied 20% excess over the theoretically required. Okay. Then we need to calculate moles of each component. For that we need to start with a basis. Always take to work out in a simple manner, try to take the basis which is present according to the stoichiometric equation. So basis is our basis is 4 say kilomoles or gram moles, whatever it is you can take, 4 kilomoles of HCl fed or charged, whatever it is, to the reactor, stoichiometric. Because if you take 4 moles directly, then oxygen theoretically required 1 mole, 2 moles of chlorine will be formed, like that all we can write. Therefore 4 kilomoles of HCl fed. That is our basis. Now each component we select and we write the balance. First, if you take HCl balance, HCl fed is equal to HCl reacted plus HCl leaving. This is HCl balance. Okay. So HCl fed is 4 moles. We want HCl leaving now. So HCl reacted we need. HCl reacted. HCl reacted is what? 75% conversion. That is 4 into 0.75. This is HCl converted. That is 3 kilomoles. Okay. Then we write this here and keep it. 4 HCl plus oxygen gives rise to 2 chlorine plus 2 water, 75% conversion. HCl and air, oxygen, nitrogen. Chlorine, water, oxygen, nitrogen, then unreacted HCl. So that is the diagram. So HCl reacted, therefore HCl leaving is equal to HCl supplied minus HCl reacted or consumed, whatever it is. So HCl supplied is 4 moles and reacted is 3, therefore 1 kilomole is HCl leaving. So HCl calculation is over. Okay. In other words, here 75% is converted, or HCl leaving is equal to 75% of HCl fed. That means 4 moles are fed, 4 into 0.75. Okay. This is 1 mole. HCl leaving is 25% of HCl fed. So this is 1 kilomole. Okay. Anyway, you can write 75% is reacted. So leaving is 25% of HCl fed. Next. Next you can, so HCl is over. Then you can take oxygen balance. Oxygen balance. Okay. Then oxygen supplied is equal to oxygen used up plus oxygen leaving. This is oxygen balance. We need to calculate oxygen leaving. Okay. So oxygen supplied we need to calculate first, and then used up we need to calculate. So oxygen supplied, for air supplied we need to calculate first. Means from the stoichiometric equation is where shall we write again here? 4 HCl plus oxygen gives 2 Cl2 plus 2 water. This is the stoichiometric equation. So, according to the stoichiometry, oxygen theoretically required is how much? Our basis is 4 moles. So, for 4 moles, 1 kilomole is theoretically required. Then, oxygen is supplied 20% excess. Therefore, oxygen supplied is equal to oxygen theoretically required into 100 plus 20 by 100. That is into 1.2. This whole thing is nothing but 20% extra means you need to multiply with 1.2. So, this is 1 into 1.2, that is 1.2 kilomoles. Okay. So, oxygen supplied we got 1.2 kilomoles. Then oxygen used up. How much is oxygen used up? Oxygen used up is theoretically required. Oxygen theoretically required into fractional conversion. Actually, according to stoichiometry, for the basis of 4 moles of HCl, 1 mole of oxygen need to be consumed. But the reaction is only 75% complete. But 1 full mole will not be reacted. But 1 into 0.75, that is 0.75 kilomoles. Only this much oxygen will be used because only 75% conversion. Therefore, oxygen leaving is equal to oxygen supplied minus oxygen used up. Oxygen supplied minus oxygen used up. That is, oxygen supplied is 1.2. So, 1.2 minus 0.75. Okay, 1.2 minus 0.75. So, how much is 0.45 kilomoles? 0.45 kilomoles. This is oxygen leaving. So, oxygen leaving is also over. Then, next, we can take nitrogen leaving. In last class, we already discussed in detail. Okay. So, nitrogen balance. So, nitrogen leaving is equal to nitrogen supplied. Okay. So, nitrogen supplied, how to calculate? Nitrogen supplied is equal to oxygen supplied into 0.79 by 0.21. So, oxygen supplied is how much? 1.2. 1.2 into 0.79 by 0.21. This is equal to so many gram moles. So, nitrogen supplied is 4.514. 4.514. Okay. Therefore, nitrogen leaving is equal to 4.514 kilomoles. Okay. Because nitrogen, how much nitrogen is entering, the same amount is leaving out. So, now nitrogen balance is also over. Next, chlorine and water are remaining. Then chlorine. Chlorine leaving is what? Chlorine leaving is equal to chlorine formed. Chlorine leaving is nothing but whatever the product that is formed, that only is leaving. So, chlorine formed is equal to chlorine to be formed according to stoichiometry. Chlorine to be formed according to stoichiometry. This one into fractional conversion. Into fractional conversion. Okay. This is chlorine formed. So according to stoichiometry here, for 4 moles of the basis, 2 moles are to be formed. So 2 into fractional conversion is 0.75, that is 1.5 kilomoles. Okay. Then same thing for water also. Water leaving is equal to water formed. Same explanation. Water formed equal to how much water? 2 moles of water to be formed actually. But conversion is only 75%. So 0.75, that is 1.5 kilomoles. Okay. So this 0.75 fractional conversion applies to each and every component in the reaction. So thus we got chlorine and water. All the components, each component how many moles are leaving, we have calculated. So composition means total moles leaving by we need to add up to get total moles. Then moles of that component by total moles into 100. We will get composition of the gaseous mixture leaving in mole percent. So first shall we list out, okay, product leaving, gases leaving. First we list out that, okay. Chlorine, how much? So many kilomoles. Then water, so many kilomoles. Then oxygen, then nitrogen, then HCl. Okay, all in kilomoles. So HCl is 1 gram mole, 1 kilomole. HCl is 1, and nitrogen is 4.514. 4.514 here 1, and then nitrogen, oxygen is 0.45, and water and chlorine are 1.5. Okay, these are the moles of each component leaving. So what are the total moles? Total moles leaving. Total moles leaving is 8.964. 8.964 kilomoles. Okay. Then percentage composition. Therefore, percentage composition of product of gaseous mixture leaving in mole percent only, in mole percent. Okay, this is each one we take. Chlorine leaving, chlorine equal to 1.5 by 8.964 into 100. Then water also same thing, into 100. Then oxygen 0.45, 8.964 into 100. Then nitrogen 4.514 by 8.964 into 100. Then HCl is 1 divided by 8.964 into 100. That is HCl is 11.15%. Okay. Chlorine is 16.733%. And water also same thing, 16.733%. And oxygen is 5.02. And then 50.35 nitrogen. Okay. So this is the answer. Composition of gases leaving. So when a reaction is taking place, by writing material balance for each component, we are able to find out the composition of the total gaseous mixture leaving out. Okay. And here one point is, we are assuming air composition as 21% oxygen and 79% nitrogen. With little error we are assuming that, because air contains not only oxygen and nitrogen, about 1% of other gases like CO, CO2, some water molecules and inert gases. Okay, all these are present now. So this is exact value is about 20 point something, and this is 78 point something. So if you add up now, there is 1 point something will remain. That consists of all these gases. But in chemical process principles, when we work out the problems, no, with little error, we assume that air consists of 21% oxygen and 79% nitrogen by moles. Thank you.